Good day, Algebra. We are here in CO63, our last objective of the year, and it's multiplying and dividing radical expressions. You want the good news?
Yes.
The good news is, if you know how to multiply and divide fractions, the process, the idea behind multiplying radicals is the same. Okay? Meaning, folks, quiet please. If you're going to multiply 3/7 times 9/10, do we need to worry about common denominators like we do with addition and subtraction? No. When we multiply, what's our process? What's done, Anthony? Not for multiplication. For division of fractions, yes. For multiplication, Anthony. Elliot?
You multiply the numerator and then you multiply the denominator.
Right. The numerators are multiplied, the denominators are multiplied, and we would get 27/70ths, which then, of course, if you can, in this case you can, then you would simplify. Okay? Never mind. You can't simplify that. I thought 3 went into 70 for a second there, but it's not. Okay? The idea is the same for multiplying variable expressions. Noah, Max, Lawrence, for each of you. What do you multiply when you multiply variable expressions? Do the variables need to be the same? No. And how are they get combined, Ellen?
You multiply the coefficients and then you put the variables just
Right. Those coefficients get multiplied together. 3 times 4 is 12. And then the variables, we don't know what they are. We don't really care. They just kind of tag along with n, y. Okay? Roots are very similar. To where if you've got a radical expression such as 5 root 3 times 2 root 7, the radicals do not need to be the same like they were for addition or subtraction. And what gets multiplied? The coefficient and the coefficient, just like the numerator and the numerator, right? The coefficient there. So 5 times 2 would be 10. And then the root and the root get multiplied, just like the denominators of a fraction. And your final answer would be 10 root 21. Okay? If you can simplify, you can. In this case, you can't. And so this would be your final answer. Okay? So again, that we see the rules for radicals very, very similar to the rules for fractions, for both addition, subtraction, and multiplication, division. Yes, sir?
Is the bad news that there's 3 pages?
The bad news is that now that we have all these tricks up our sleeve, we can get somewhat advanced in our multiplication expression. If you missed Old Man Foyer or Crab Claw, I've got good news for you later. Yes, Alex.
So are we doing the 4 and 5? So if that was 20, and you could do 4 and 5.
Where you see 4 and 5?
The next question is.
Oh, we're not there. We're not there. Ellen, more to you. Okay. Any questions on what we have so far? Yes, Elliot.
16 root 20.
We're not there yet. Hold on.
That was the simplified.
He raised his hand.
Yeah.
Okay. Okay. So down in the practice section here, our first one, we've got 2 times 8, right? Those coefficients. Then we have our root times our roots, which do not need to be the same, thankfully. I don't know why I'm writing a fraction. Because we can multiply them. And we do indeed get 16 root 20. Can we simplify, Jack? How?
Yes. You can find the factor pair of 20, which is 4 and 5.
Good.
Then simplify the 4 to be a 2 or whatever. Then you multiply the 2 by the 16 to get 32, I think. And then that's the answer.
Is 32 root 5 would be your final answer. Perfectly set. Or whatever. Okay, maybe. Perfectly set. The next one, 9 root 8 times 3 root 5. Raise your hand if you can walk me through our process for this. Burgess, go ahead.
27.
Yep.
9 and 3, you have to multiply that to 27.
Yep.
8 and 5 is 40.
Okay.
And then root 40, you can simplify to 4 and 10.
Good.
4 equals 2. And you got 27 times 2 times root 10, which is 54 root 10.
Fantastic.
I was saying,
Let's go, Will.
That would be our final answer. So, Damien, it's not what you got. Here's the work going through it. Did you get 27 root 40 here?
Yeah.
Okay. Did you break 40 into 4 and 10?
No,
What'd you break it into?
I didn't break it.
Okay,
That's
so
what
then-
they both had to be able to.
No, only one of them. If they both a perfect square, then your original number would be a perfect square. But you're only looking for one perfect square factor. Okay. Next one. Who wants to walk us through that? Sophie.
11 and 2 is 22.
Yup.
6 and 3 is 18.
Okay.
2 for 18 and 18 is 9 and 2. 9 is 3. 22 and 3 is 66.
And so 66 root 2 would be our final answer. Alex.
I'm the last one. Since 8.
Are we looking at the last?
Shh. The last one we did, Joey. Just calm down.
Could you? Because 8 can be 4 and 2.
So you broke 40 into 8 and 5? You mean? Or what?
No.
No.
So at the start, 8 you can simplify 4 and 2.
Oh, so you're saying, should you simplify this root first?
Yeah.
You certainly can. It wouldn't make a difference. Yeah, Alex is asking way back at the start, should we break down root 8 before we multiply by 3 root 5? You certainly can. It would not affect your final answer. You would get the same thing. Okay. The next one. We've got a fraction times a fraction with roots. Again, since we're multiplying fractions, do our denominators need to be the same? No, which is a huge plus. It's almost like multiplying is easier. There are less rules than adding and subtracting. So, like fractions, we would multiply straight across. Okay? So our numerator would become what? 6 root 15. And our denominator would become what?
9 root 6.
9 root 6. Okay? Now, we've got to always be thinking about how can I simplify, what can I do to break this down? Okay? Arlene,
If you simplify the coefficients, you have to simplify the roots.
you have to simplify everything you can. So, what do you want to start with?
The 6.
Sure. We can simplify 6/9, right? Being coefficients, it's like a fraction, and that would bring us to 2 root 15 over 3 root 6. Now what? We simplify the 6/9
Yeah.
to be 2/3.
Oh.
6/9 to be 2/3. Now what, Lisa? Okay, we could simplify the fraction 15/6 here, dividing both by 3, and that would give us 2 root 5 over 3 root 2. Okay, we're simplifying our 15/6 there. I hope we're almost done because we're almost out of space. Kylie, now what? Rationalize. And we're going to multiply 2 root 5 over 3 root 2 by root 2 over root 2. To rationalize here, you only have to multiply by the root, right? You don't have to multiply by 3 root 2. Only multiply by the root 2. What does that give us in our numerator? Elliot?
2 root 10 over 6.
2 root 10. Root 5 times root 2 is a root 10. We have a coefficient 2. And then these root 2 times root 2, right, becomes just 2. The roots cancel out. And you multiply by our original coefficient 3, and that's where we get 6. Arlene?
Simplify that to
Oh, we're out of space and we're not done yet. Hate when that happens. Now we can simplify our 2/6 here. And so what is our final answer, Beckman?
1 root 10 over 3.
Root 10 over 3. Root 10 over 3. Catherine?
Can that fraction be extra credit on this one too?
Yes.
No.
What?
You gotta learn how to do this.
The ones with variables can be extra credit, but not your standard numbers. Burgess.
On the top, how'd you get 6 and 9?
I multiplied straight across here. 2 and 3 is how I got the 6. And then root 6 times 9. Root 6 and 9 can't actually be combined because one's under root, the other one isn't. So you have to keep them separate in a sense. 9 root 6. Okay. Arlene.
When you simplified root 15 and root 6, did you divide them by a root or just by 7?
Essentially divided them each by root 3. Yeah. Root 15 divided by root 3, root 5, root 6 divided by root 3 is root 2. Okay. See what you can do. Yes, Damien.
For that last one, the 2 root 5 and the 3 root 2, couldn't you just do 5 times 2 and then bring the 3 down to 10 root 6?
That's kind of what I did. Yeah.
But too much work is what you said.
Well, I'm showing every step. Because again, with these multi-step things, with all this simplifying, the less work you show, the more opportunities you open the door for mistakes. I said that wrong. The more doors are open for mistake opportunities. The more mistakes, doors open for opportunities.
You're just making it
What
worse.
are you saying?
You're just making it worse.
I
Opportunities,
have no idea.
more mistakes, doors for open.
Okay.
What?
But-
Think about that one.
But
Now
that
it's
one
on
helps you.
purpose.
That's
Ellen.
Are the variables like that? This one also extra credit?
Yes, I'll have variable ones as extra credit also. Looking ahead,
Oh, we're on the
if you missed Old Man Foil or Crab Claw, we've got good news for you.
Oh. Nope. Absolutely.
Okay. Let's look at the second one here. We've got essentially 2 binomial expressions, right? There are two termed expressions here. And whenever you've got 2 binomial expressions, the FOIL, crab claw, even the box method, all come into play here. Okay? Any method that you want to use to multiply these, you could use. Right? Who is still a fan of Old Man Foil?
Oh,
He appreciates that. Who is a crazy for crab claw? Nice. And who prefers the box? Very good. A nice mix. Nice mix. However you prefer to do it. Folks, however you prefer to do it, give it a try here. Okay? Foil, crab claw, box this. The rules for multiplying, if you're going to start with either foil or crab claw, this 2 root 2 times 2 root 3. Remember, you can do it because with multiplication you do not need those common roots. Okay, you start out with a 4 root 6. All right, 4 root 6. Give it a try. I want to pause the video, give you 45 seconds to do it, and then we'll see. All right. Well, I forgot to hit record, so here's what you get for that middle one. We've got all 4 terms from the multiplication written out. Just a reminder, once you do this, your 4 root 6, minus 24, 6 root 5, negative 6 root 30, they all get written as addition or subtraction. We can't go any further here because now that we're adding and subtracting roots, well, you don't start talking to Vince. The whole point was to just break that whole pod up. No, you don't start. Now we go back to our rules for addition and subtraction of roots, but you can't do anything here because we don't have any like roots to combine. Well,
How do you get negative 24?
negative 24. So, do you understand how I got this here? Okay, so putting this over here, negative 12, root 4 is a perfect square. It equals 2. So I would simplify that, and negative 12 times 2 is what gets negative 24. Okay? Got it? All right. The last one, another foil crab claw boxing method here. Okay? So we're going to start by 6 root 3 times 3 root 2. What is that one? Give me
18 root 6.
18 root 6. Right? 6 root 3 times negative 5 root 18 gives me what?
30 root 54.
Negative 30
4.
root 54, which that can be simplified, right, Arlene?
You get negative 90 root 6.
Yep, you end up with negative 90 root 6. 9 and 6 is the factor pair that you want for 54. The root 9 becomes a 3, right? This breaks down into negative 30 times root 9 times root 6, or negative 30 times 3 times root 6. And that's where the negative 90 root 6 would come from. So already here, can we see that we're going to have some addition or subtraction to work on or to complete?
Yes.
Yes, because we have those like roots with the 18 root 6 and the negative 90 root 6 there. Okay? So the last one, Joey, shush. It really is a lot easier if we just, just do it and not have all the exuberance of, okay, all the moaning and the groaning, exactly. Don't need it. Negative 7 root 2 times 3 root 2, what does that give us? Initially,
21 root 4.
negative 21 root 4, which that can be simplified to be negative 42, right? That root 4 being a perfect square equals 2. Okay, so negative 42. And our last calculation, negative 7 root 2 times negative 5 root 18.
And 35.
Initially becomes 35 root 36. Again, coefficient times coefficient, root times root. And how can this simplify, Kylie?
36 on perfect square.
Yep.
6.
Yep. And what's 35 times 6?
210.
Woohoo! I didn't believe you for a split second there. There's already 180 in my mind. That's
Wouldn't it be
30 times 6,
105?
not 35. Okay, so now we look at our 4 terms that we have here: 18 root 6, negative 90 root 6, negative 42, and positive 210. And when we write them out horizontally, 18 root 6 minus 90 root 6 minus 42 plus 210, we see that we've got 2 sets of like terms that we can combine, right? Those common roots in our radical expressions. We've got 18 root 6s. We subtract 90 root 6s. How many root 6s do we have in all? 8.
Negative 72.
Negative 72 root 6s, right? And then we have our constants, a negative 42 and a positive 210 becomes a positive 168. And so this would be your final answer. Can't go any further here because we've got a root 6 term and a constant term. Can't combine them, right? There we have it.
How do you do the first one?
The first one, how would you do this first one? What would your process be here? Sophie? Just distribute into parentheses. Okay?
Okay.
Half crab claw.
And then you do
Crab. And then you do the bottom stuff. Right. You simplify where you're able to.
We have to do that one.
Your homework for Tuesday.
Wait, do we not do
Okay.
tomorrow?
Tomorrow's a retake day, so we're not going to check in here. The rest of the top part of this page, so that's one question basically, and then I want you to give this one a shot here.
We don't have to do the variable. Wait, which one?
The variable ones will be extra credit, so if you want to give them a try, then you can. But what will be required is only 2 questions. If we don't end on the number game next week, then we've done something horribly wrong. The 2 you need to do for Tuesday.
It's not optional.
The 2 you need to do for Tuesday are circled up on the board.
Keep it there. I had to. Never mind.
Not an attempt to completion. Okay?
Sorry, I'm like really.
Yes. What's circled on the board is what you need to do. Okay? What you need to do. All right, that is how you math.
Don't forget